Okay, so in this video we're going to be rotating these two shapes around the y-axis, and then we're going to be finding the volume of the space between them. So the space in between them is here, that kind of semicircle looking thing, and then we're going to rotate that all the way around the axis, so it's going to meet up back here at this point and create this three-dimensional shape. So the way we do that is first we have to look at them as individual lines. This line here is going to rotate outward off the page, meet up here with the same plane once again, and kind of look like this. And then it's going to go back behind the page and meet up here. So you're getting this kind of sphere object. And then this semicircle as well, going to do that same thing. It's going to come out and around, and it's going to meet back up with this plane here. And you're going to get this, also this kind of semicircle effect. It's going to go back behind the page and create the semicircle, or the complete sphere, once it goes all the way around. So then to illustrate this a little bit better so that it's not kind of muddied up by my poor drawing skills, I'm going to just add these circles like this. And what that is not the full rotation, it's just that line reflected about the y-axis and then just not the other side. So it's just kind of that two-dimensional shape that you get, and then three-dimensionality is going to come from when this line comes off the page and meets back up with this point, and then it also goes behind and meets back up with this point. So I just left this space in here because we do have this other sphere inside which is also rotating. So that thing's going to come out and around. And then let's do a dashed line for the back side, where that line does go actually behind the page. Okay, so we got arrows here. The front side is going to be solid, and in the back we're going to have dashed. Okay, so that line is going to come out and around, meet back up with that plane, and then come out and around here. So what's happening here is we have one big sphere, and then it's hollowed out by this sphere in the center, because remember, again, we are taking the area of we're taking the volume of the shape around it. And that volume, it does have space here in front, because you kind of have to think about this like this is a giant ball, right? We have the purple part, and then we have the inside line. That looks like the Death Star. We got this inside line, and then this is kind of like a hollowed out center of the entire line. Get rid of the Death Star there. Alright, so hopefully we're able to visualize that part of it. Again, this is a giant purple sphere, right? And if we didn't have the green inside to take out, it would just be this giant purple sphere. But we have this area here which is taken away from that sphere's volume. It's kind of like, I don't know if any of you have ever had the candy where it's like a giant chocolate ball, but then there's the inside which is hollow. It's like that. That's what we're dealing with here. So to be able to find that volume, we're going to have to take the volume of the original, so the large sphere, I'm going to make it purple so it matches, and then we are going to have to subtract the volume of the small green square, or green sphere, right? So we have to find the volume of the original, the large sphere, and then take out the volume of the green sphere. So hopefully we are familiar with the formula of a sphere. If not, you're totally fine to look it up for this assignment. So 4/3, this is the volume of a sphere formula, times pi times r cubed. So we're going to have that for the large purple sphere, and then we're going to subtract the formula for the, I want to make that green so it matches, the formula for the small sphere, 4/3 pi r cubed, and that would be the radius for that sphere. Notice they have different radii because they're not the same size. Okay, so let me actually just copy and paste this because we're going to use it again. Only this time we're going to know what the radii are. So let's find the radius of the purple sphere first. So the radius of the purple sphere is from this point here in this very center out. So it goes from 0 to 2. So the radius of that sphere is 2. So I'm going to remove the radius and say, okay, that's just going to be 2 cubed. Now let's find the radius of the green sphere. That is from, you can also do it this way, but I don't want it to get muddied up, 0 to 1, but you can do a radius in any direction. So let's go this way as well. The radius here is 1 because it goes from 0 to 1. The radius of the larger sphere is 2 because it goes from 0 to 2. And no matter where this is located, even if these objects are shifted up, you're still just going to want to find the radius. So even if it doesn't start at 0, let's say that this goes from the center to 4, that's also a radius of 2, right? In this hypothetical other sphere that I could draw. Just as an example, just something to look out for, that might be different, right? So right now we have a radius 1, and we have a radius 2, and they do start at 0, but it's okay if that this whole circle is shifted up and there is a different radii. That's okay. Okay, so because that radius is 1, I'm going to remove that and I'm going to just say, okay, that's 1 cubed. Now I'm just going to plug all this information into my calculator. 4/3, here's the first part for the larger sphere, pi times the radius cubed, minus the hollow part, which is 4/3. Sometimes the calculator is confused about what you're doing. 4/3 times pi times the radius. Radius is 1 cubed. And then if you're really comfortable with your exponents, you could tell that 1 cubed is just 1, so it's actually not necessary because you're multiplying by 1. So they're actually the same thing. Or it's the same thing with or without the 1 cubed because that's multiplying by 1. It doesn't really do anything. Okay, so it looks like the volume of this interesting shape we've got here, that's kind of like that candy with a hollow center, is 29.3. And then again, we're not doing units here, but if you did have units, whatever units you're measuring it in, this would be units cubed because it's a volume. But I'm not expecting units on this assignment.